Hello again, Mr. Boothman, and we are back talking about the second half of section 5.5. There's only two other kinds of transformations. We talked about A, changing the amplitude, B, changing the period. Now we're going to talk about something special called a phase shift. This is going to be the C in our standard form. And if you remember from our other kinds of transformations, it's in the parentheses, I'm affecting x. That's going to be a horizontal shift to the left or to the right. We have a special name for this in trigonometry. We call it a phase shift. I know it sounds a lot cooler than it is, but it's just a horizontal shift to the left or to the right. So if I have y equals the sine of x plus pi over 2, plus pi over 2, I'm in the parentheses. I'm actually doing the opposite in terms of the shift. So I am subtracting pi over 2 from all my x values. I feel like it should be moving to the right pi over 2, but it's the opposite. I'm moving to the left pi over 2. So I'm starting here and doing this. And then cosine works the same way. Let's say I have cosine of x minus pi over 2. I feel like I should be shifting back to the left pi over 2, but really I'm adding pi over 2 to my x values. I'm shifting it to the right. So I'm starting at 1, here, 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 and so on. All right, so phase shift, not too bad, but I do want to stop and look at what happens when we have all of these transformations put together. So let's look at letter A. I have the cosine function. So if they want us to find 5 key points, I'm going to start, like I told you in the last video, with just the normal table for y equals the cosine of x. And then we'll transform these points and get our get our new transformed points without having to do any extra work. So regular cosine of x, and now I follow the order of operations. I'm looking in the parentheses first, x plus pi over 2, but we know it's in the parentheses. I need to do the opposite, so I need to subtract pi over 2 from all my x values. So this is different from when I had a period change. When I had the period change, I ignored my existing x values, and then I found new ones, my new period, and then I divided by 4 to get what each interval equaled. Here, I am taking my existing x values, and I'm subtracting pi over 2 from them. So negative pi over 2, 0, pi over 2, pi, and 3 pi over 2. And then I can look out of the parentheses. I see negative 2 in front. That's affecting y. I just need to multiply my y values by negative 2. So I have my new points here, and I could go ahead and graph those if I needed to. So the plus pi over 2 was a phase shift, pi over 2 to the left. The 2 was changing the amplitude. I made the graph taller. The amplitude is now equal to 2. And then the negative, just like before in our transformations, it would flip it over the x-axis. It's a reflection over the x-axis. And we would see that if we plotted these points. I want to go through letter B also, just because something special, something a little different is happening here. I have both a B and a C in this case. Now, when that happens, my phase shift is being affected by that B. The period change is affecting the phase shift just by looking at this right here. So what I have to do first before I can actually look at my transformations is factor out B from what's inside the parentheses. And if I do that, 4 times x minus pi divided by 4, factoring is dividing. This is actually what's inside my parentheses here. It's the same thing. I can go ahead and redistribute that if I want, and I'm going to get 4x minus pi back in the parentheses. But now this is my period change, and this is my phase shift. Okay? It's hard to understand why that's going on. Basically, the period change is going to affect the phase shift. It just does, which is why we need to take that into account before we just look at our graph and make our phase shift changes. But we make our table of values the same way. This is a sine function. I'm changing the period first. B is equal to 4. So my new period is going to be 2 pi over the absolute value of 4, which is pi over 2. So my new period, I'm going to ignore my existing x values from 0 to pi over 2. And then I need 4 equal steps in between there. So take pi over 2, divide that by 4. It's going to be pi over 2 times 1 over 4, which is pi over 8. So I'm adding pi over 8 each time. And then I can look at my phase shift. Minus pi over 4. I'm in the parentheses. I do the opposite. I'm adding pi over 4. So pi over 4. Pi over 8 plus pi over 4. Yes, I'm making you think about fractions. It's going to be 3 pi over 8. Pi over 2. 5 pi over 8. And then 3 pi over 4. If you need help with fractions, let me know. Minus 3 from the y values. And then I could graph. I've transformed points. Now this minus 3 out here is actually going to be our next topic. I'm going to go ahead and skip these examples. We do ask that you do number 4 to be eligible for the retake. But go ahead and talk to me about 1, 2, and 3 if you're stuck on any of them. We've had plenty of examples in class, so that's why I'm skipping them. We're going to go right to the last kind of transformation. That's a vertical shift. It's a vertical shift up or down. I'm changing the midline. We also call this a midline shift. Remember, the midline is that horizontal line going right through the middle of the wave. And so when I add or subtract something to y, that is the line that I'm moving up or down. So if I have y equals the sine of x plus 1, that's a vertical shift up 1. I'm outside of the parentheses. I need to do what it says. And my new midline is at the line y equals 1. So instead of my midline being the x-axis, my midline was shifted up 1. So that's now where I'm starting my graph. The entire wave was shifted up 1. If I have y equals the cosine of x minus 1, that's down 1. My new midline is y equals negative 1. So instead of the x-axis, I shifted down 1. Now that's where I'm starting. Oops. And actually, I just graphed that incorrectly. There. Sorry. It's tricky using this. All right. So I'm going to do one example, and then, oh, this is number 5 twice. Sorry for that. You'll do this number 5, the second number 5, to be eligible for the retake for this. But I'm going to look at the first number 5. Start with your table of values for the cosine. I know this video is not terribly exciting, but this is setting us up to be able to do more exciting things with trig, I promise. And now we go through the order of operations. So I have a b, so my new period is pi. I'm ignoring all my existing x values. I'm changing them. Divide it by 4 to get what I'm adding each time. And then I have an a, order of operations outside the parentheses or outside the function. Now I'm adding, or not adding, I'm multiplying. In this case, I'm multiplying y by 3. And then my last transformation, the midline shift, the vertical shift, was that d plus d in my standard form. So I'm adding 2 to my y values. And so now I can graph this. 0, 5, call this pi over 2, pi over 4, 2, pi over 2, negative 1, 3 pi over 4, 2, and then pi back up to 5. So this is a really stretched graph, like that. All right, so this is how I do it. If you find the way Miss Parker does it simpler, that's totally fine. I just like seeing all of these points. This requires a lot more fractions, but I do think that's an excellent skill to build no matter what you intend to do in your life. Please write down your questions, work on these practice problems, let me know, and I will see you again in section 5.6. Thank you so much. Have a great day.